Okay, so in this lesson, we're going to talk about end behavior of polynomials now. We've done some end behavior of other functions. We're going to talk about some different polynomials. All right, before we start, I just wanted to review a few things. First of all, just as a reminder, this right here is called a base. This number 3 here, that's called an exponent. The number in front, this right here, is called a coefficient. Okay, so 5 is my coefficient. And remember, that would mean 5 times x times x times x times x times x. Need one more. That's really what this means, right? But the number in front is your coefficient. Okay, and then one other thing, just as a reminder, when you see just a nx, there's really a 1 here. So my coefficient is 1 there, but also there was also an exponent of 1. So there's 2 hidden 1s there. So just a reminder about a couple of those things. Okay, so today we're going to talk about polynomials. What is a polynomial? It's one or more terms put together by addition or subtraction. So here on this next slide, I have a couple of examples of that. Even something like 13x squared is a polynomial. It just has one term. But if it has more than one term, like this is a quadratic function, it has 3 terms that are put together by addition and subtraction. So that's called a polynomial. Okay, and then you can see sometimes you have more than one variable. Really, the key thing with polynomials is that they have no variables in denominators. Or exponents in denominators, and also no roots or absolute values of variables. All of my variables have whole number exponents. That's the case. So all of those are polynomials. It qualifies here. Okay. How do you find the degree of a polynomial? It's pretty simple, really. You just find the degree of each term, and then whatever one is the biggest is the degree of your polynomial. So for example, if you looked at this, the degree of that is 6. The degree of this is 4. The degree of this is 2. So the degree of the polynomial is the biggest one, 6, that one, and that's it. So really you just need to find whatever one is the biggest, right? And that, in this case, this one would have a degree of 8, since this is my biggest degree term. Okay, now sometimes you'll have multiple variables, and then it's a little bit trickier. If you have multiple variables, to find the degree of the term, you have to add all of the exponents for that. So I'd say 4 plus 2 plus 3, that's 9. This one, remember the c would really have an exponent of 1. So it'd be 4 plus 3 plus 1, which is 8. And then this one would be 5. So the degree of this polynomial, even though it's a little different looking, would be 9, because that's the biggest one. That's how you find the degree of a polynomial. Okay, standard form is you put the terms in order from biggest to smallest. Now, we actually have been doing this when we did long division already, so you kind of already are aware of that. Also, the leading coefficient, that's going to be the number that's in front once the polynomial is in standard form. So we're going to try this on the next slide, but those are just a couple of terms. But you kind of already know this. We've already discussed this a little bit earlier. All right, so let's just try. So let's say I gave you this polynomial, and I said to write it in standard form. Well, what I want to do is look at the degree of each one of these terms. This is a 1, this is a 5, 3, and 0. And I would put them in order. Remember, the sign that's in front of the term always goes with it. So this one, the biggest one, would be negative 7x to the 5th. So that's going to be my first term. Then plus 4x to the 3rd. And then plus 6x. And then minus 10. So I just work my way down. In this case, I'd be 5, 3, 1, 0. Okay. Now, my leading coefficient is simply the number in the very front. My coefficients are negative 7, 4, 6, and negative 10. but I want the leading one. So once you've put it in standard form, my leading coefficient is -7. Your coefficient should always just be a number. So a common mistake is that sometimes people do this. That's not a coefficient. We just want the number in front, so that would be -7. And then what is the degree of this polynomial? Well, since the biggest degree term is 5, my degree is 5. Okay, so those are the 3 key things we should be able to find when we have a polynomial, is what's standard form, what's the leading coefficient, and what's the degree. All right, so one more, just to make sure we got it. We're going to put this one in standard form. Okay. All right, so y to the 7th is the biggest one. Then 3y to the 5th. Then minus 9y to the 4th. So I've done these 3. Now I've got 2y squared, so plus 2y squared. And then plus 8y. And then minus 81. Okay. Now, what is my leading coefficient? Well, what number's really here? It's really a 1, right? So my leading coefficient is 1. What's the degree of this term? The biggest degree term is 7, so the degree is 7. That's it. Okay, hopefully that makes some sense. All right, let's talk about end behavior for polynomials. Okay, so here are a couple of different polynomials and their graphs. Let's examine this one first. So end behavior, as x goes to infinity. So remember, we always kind of start in the middle and go this way. So as x is going to infinity that way, what's happening with f of x? You can see it's going up that way to infinity. Okay, so then, what about going this way? As x goes to negative infinity, what's happening with f of x, or y? It's also going up, right? So also going to infinity. All right. Same thing here. As x goes this way, what's happening? It's going down. This one is to negative infinity. As x goes to negative infinity, what's happening? This one's going up to positive infinity. So we did some practice with this with our in our last unit, so hopefully that makes some sense. We're gonna start to generalize some things, and that'll make our life a little easier. Okay, so I have a table at the bottom, and we're gonna fill this table out a little bit. So we have a couple of different graphs, and what we're gonna look at is their degree and their coefficients. So this first graph up here, I'm gonna put degree 3, okay? And this one has a leading coefficient, right? That's -1/2, okay? This one has a degree of 2, and the leading coefficient, I'll write it up here, is +3. This one has a degree of 3 and a leading coefficient of +2. And then lastly, this one has a degree of 4 and a leading coefficient of -1. All right. So now let's fill out this chart. We have all these different graphs. What do they look like? All right, positive leading coefficient and an even degree. So that would be this one right here. Even degree is 2, and then the leading coefficient is positive. What do you notice? You'll notice that on both ends it goes up. So I'm going to generalize this by saying on either end, they're both going up. Okay, so now let's try odd degree and positive leading coefficient. Fill out this box. All right, so let's see, odd degree and positive leading coefficient right there. All right, so you can see on this end it's going up. So as we go to the right, it's going up. And as we go down here, it's going down. Okay. All right, now let's do negative leading coefficient and even degree. So that would be this one. Okay. Looks like that way. And then as we go to negative infinity, it's also going down. All right, and then lastly, negative leading coefficient and odd degree, this one. Okay, so as we go to a negative infinity, it's going up. As we go to a positive infinity, it's going down. All right, so really we can use this chart. This happens, or this generalized patterns happens for all polynomials. So I'm going to copy this. And we're going to use it for this. So let's see. Let's just paste this image in here. Oh, it didn't bring everything in, but okay. Well, that's okay. All right. So what is the degree of this term right here? The degree is 3. The leading coefficient is 1. So I have odd degree, positive leading coefficient. So if we come up here, odd degree, positive, so it's that, right? So if we're looking at, I'm really looking at this one. Okay, so as x goes to infinity, that would be this one. F of x is going also up to infinity. As x goes to negative infinity, that would be this one. You can see it's going down to negative infinity. Now, even if I don't have the graph, I know that that's the case. You can see that in the graph, but I wouldn't even need the graph to know that. I can just use this pattern here. Okay. All right. This function here, it says, looks like the degree is, oh, I missed the degree on this one. This one should be 5, not 3. But that still works because it's an odd degree. So sorry, I missed that. All right, this one, degree 6. Okay, and my leading coefficient is -9. My leading coefficient on this one would have also been positive. It would have been 7. Okay, and still works. Okay, so now on this one, all right, if I go back up to degree even and negative leading coefficient, both ends should be going down to negative infinity. So let's see. Yep, my graph confirms that right here. So to negative infinity, negative infinity. Okay. And then the last thing that I want to just go over is determine which function belongs to each graph. So probably what you want to do is just identify each of these graphs. So this one, right, it goes like that, okay, on either end. So if I go back and match that, right, I'm looking at, it's this, let's go up to this part right here. It is this one. So I know it's odd degree, positive leading coefficient. So I'm going to write that. Degree, odd, LC, positive. Okay, so I'm just going to start with that. All right, now this one over here, both ends are going down. So let's go back to our chart and see how that works. All right, both are going down. So that's even degree, negative leading coefficient. All right, so this is even and negative leading coefficient. All right, so now we're just going to look at our functions and see if we can match those up. Okay, so this f of x has a degree 4, and the LC would be 5. Okay, so that doesn't work because degree is even, LC is positive. So maybe it could have worked for this one here, but nope, the degree. So that one is out. That one doesn't work for either one of our cases. All right, this one, h of x, degree is 5, and the LC is 7. So odd and positive. So it appears that that would match our first one here. So let's just double check, but we think that this one is going to be h of x then. Okay, let's go through them all here. All right, I'm going to switch colors. All right, and then this one has a degree of 8 and an LC of negative 2. So even and negative LC. So that appears to be this one, we think. Okay. So now, what about this last one? I got a degree of 3, which is odd, and an LC that's negative. That one doesn't happen anywhere. So here are the two confirmed graphs for each of those. Now it says explain your choice. Well, because I started with this already explains it. I don't really have to go any further than that. So that might be a good way for you to start as well. Okay. And that is really it. Hopefully that makes sense. You kind of have a heads up because you've done some of these concepts before. Yeah, hopefully that makes sense. Go ahead and give the assignment a try. See ya. Bye.